In this video, I'll be explaining to you the Apache Hadoop and why it is important and required to understand the Hadoop architecture and its core components, and also the idea of Hadoop ecosystem along with listing of supporting softwares available under this platform. In this video, I'll be also explaining to you the concept of MapReduce with the help of case studies. What is Hadoop? In the first place, Hadoop is an open source implementation for Google MapReduce, which is based on simple programming model developed by Google. Further, Hadoop is an Apache open source software based on Java framework. It is developed for distributed processing using large clusters of nodes over big data. To understand big data, please refer my video lecture on Introduction to Big Data. The large clusters of nodes include hundreds of thousands of computers. That means Hadoop runs on a large cluster of commodity, that is cheap or low configuration machines called data nodes. Also, along with MapReduce processing techniques support, Hadoop also provides both distributed storage as well as processing of large data sets, including stream data using Hadoop distributed file system. We will talk in detail about Hadoop distributed file system later in this video. The Hadoop design principle include handling of big data with parallelism and across many clusters with thousands of data nodes called slaves, having low-end commodity hardware and small number of high-end expensive name node known as masters to support an automatic recovery and fault tolerance. Such commodity machines working in parallel to solve a computing problem with very little redundancy. Point to be noted here is that it needs only a small number of high-end expensive machines in contrast to parallel databases. There is an automatic parallelism and distribution of jobs along with data to different data nodes across various clusters which are hidden from an end user. Fault tolerance and automatic recovery is supported by secondary name node in case of the failure of the primary name node. There is a MapReduce processing technique which will be discussed later in this video. This MapReduce processing technique uses only two functions, map and reduce, to provide fast and simple programming abstraction. Characteristics of big data demands a simple solution which is provided by Hadoop, and need of Hadoop is to facilitate big data storage and processing of stream data, which may be structured, semi-structured or unstructured data using simple programming models using only two functions known as map and reduce. Rather than data, the computation is moved to all the data nodes which are present on large cluster of commodity hardware. These on the nodes with only 3 redundant copies of chunk blocks having it. The high scalability is possible due to the facility of making chunks of given large and rapidly growing data set, which is handled by Hadoop distributed file system, where the fault tolerance is possible due to availability of a secondary name node, which takes over whenever primary name node fails. Now, let's go through the Hadoop architecture. This architecture is a master-slave kind of architecture where the master is called as the name node and the data nodes are treated as slaves. Once the job is submitted by the client, Hadoop distributed file system splits data files into one or more blocks or chunks assigned to the data nodes. These blocks are the block size is 64 MB or 128 MB, which is based on Hadoop version. The name node controls the access to the data node and it maps the jobs and respective data blocks to the data nodes that are running and responsible for performing these jobs. Each data block is replicated to 3 different copies which are assigned to 3 different data nodes, out of which 2 data nodes belongs to the same cluster and 1 data node belongs to a different cluster. This arrangement policy provides high availability by the Hadoop system. Remember that the block replication factor is reconfigurable under Hadoop interface. To understand Hadoop architecture, let us list and describe each of these components labeled in this diagram. The core components of Hadoop are listed here. Hadoop distributed file system, abbreviated as HDFS, is designed to run on commodity machines which are configured with low cost hardware. The distributed data is stored in HDFS file system which is highly fault tolerant. HDFS is a Java based scalable system that stores data across multiple machines or nodes without reorganization, and it provides high throughput access to the application which require the support of big data. HDFS exhibits properties such as large storage, replication, failure handling, and fault tolerance. HDFS instance may consist of thousands of servers, each storing part of file system's data. In case of replication, each data block is replicated many times. By default it is 3, which can be altered as discussed in the earlier slide. Here failure is the norm rather than exception, and the fault tolerance supported by detection of faults and quick automatic recovery is a core architecture goal of HDFS. Name node is the heart of Hadoop system, where it manages the file system namespace and stores the metadata information of the data blocks. This metadata is stored permanently on a local disk in the form of a namespace, image, and edit log files. Name node also knows the location of the data blocks on the data nodes. However, the name node does not store this information persistently. Name node creates block and maps it to data nodes when it is restarted, and if the name node crashes, then the entire Hadoop system goes down. In such situations, the secondary name node comes into play. Secondary name node has responsibility to periodically copy and merge the namespace image and also edit the log file. In case if the name node crashes, then the namespace image stored in the secondary name node can be used to restart the name node. Data nodes store the data blocks and retrieve them as and when required. Data nodes also report the blocks information to the name node periodically. It is also responsible for storing the actual data in HDFS and notifies the name node of what blocks it has and can run on any underlying file system, say ext or NTFS etc. The name node replicates block 2x in the local rack and 1x elsewhere. That is, out of 3 copies, 2 copies are assigned to 2 data nodes in the same cluster and 1 copy to another data node that belongs to different cluster. The responsibility of job tracker is to schedule the client's job with the help of name node. Job tracker creates map and requests data nodes to reduce tasks by scheduling the job to run on data nodes with the help of task tracker. Job tracker also checks for any failed task and reschedules the failed task to another data node having replicated data, and if not available, then replicate the data block or make one available from another cluster. Job tracker can be run on name node or a separate node. Job tracker is the master node, runs on the name node and receives the user's job to decide on how many tasks will be there to run. It also decides on where to run each map per concept of locally or globally. It splits up data into small tasks called map and sends it to the task tracker in each data node. Task tracker is the slave node which receives the task from job tracker. Task tracker runs on each data nodes, and its responsibility is to run the mapped task to reduce the assigned task by the name node and reports the status of the task to the name node. It runs the task until completion, either map or reduce task, and it always in communication with job tracker, reporting progress. The task tracker nodes reports back to the job tracker node regarding the job progress and sends reduced data or requests to new job. MapReduce engine has 2 main components, mapper and reducer, which altogether runs with the help of different types of nodes present in the Hadoop system. MapReduce is not designed for iterative processes. It does not revisit data. Mapper and reducers are users' code in terms of different functions. We just need to obey the key value pair interface, where key is distinct object or index and value is expected result such as average, sum, mean, count, so on and so forth. However, before mapping, it is important responsibility of the developers to decide on what will be the key and what will be the value in the given application. The shuffling and sorting is a hidden phase of mapper and reducer. The shuffling and sorting based on pair, it groups all similar keys as received from all mappers, sorts and passes them to the certain reducer in the form of key value pair. Reducer based on pair combines values all keys of a single mapper. Here comparatively less data needs to be copied and shuffled at the data node. To understand the MapReduce engine, let us consider a case study on counting distinct words in a given dataset, which exhibits characteristics of big data. Using this case study, we will try to understand the concept of MapReduce by considering a word count example. I understand that this diagram is difficult to read. As we know, the first and foremost thing is to write mapper and reducer code in terms of functions, and these functions define jobs. Here the job is to count the occurrences of distinct words on a given data, and note that this data exhibits the characteristics of big data. Remember that the second important thing is to collect this data as shown in the first column in this diagram. As we also know that this data exhibits characteristics of big data, that is, the data files could be text, PDF, doc file, a folder containing different types of such files, which could have different structure and representation, and also may have file storing stream data where only a part of data is received so far. By this time, it is also clear that the data is split into blocks as shown in this second column in this diagram. These blocks along with the job are mapped to different data nodes. In the first column, each data node performs job of counting words on the given data based on the pair. As each data node may have its own set of calculated pairs, we need to arrange together all keys and values calculation performed at various large number of data nodes. This arrangement carried out at shuffling and sorting stage as shown in the fourth column in this diagram. As shown in the fifth column in this diagram, we get reduced pair after all the keys and their respective values are shuffled and sorted. So finally the reducer based on pair combines results by adding the values of all keys of all data nodes as shown in the rightmost column of this diagram. This is what typically happens under a MapReduce processing technique. Let's understand the Hadoop ecosystem. Hadoop ecosystem is Apache's open source software framework for storing, processing, and analyzing big data. Other software components that can run on top of or alongside Hadoop and also have achieved top-level Apache project status include Hive, Pig, HBase, Flume, Scoop, Oozie, Mahout, Zookeeper, Spark, and so on, so forth. Hive is an SQL-like interface to Hadoop. It is an abstraction on top of MapReduce to allow users to query data in Hadoop cluster without knowing Java or MapReduce. It uses HiveQL language very similar to SQL. Pig is an alternative abstraction on top of MapReduce. It uses a data flow scripting language called Pig Latin. The Pig interpreter runs on the client machine. It takes the Pig Latin script and runs it into a series of MapReduce jobs and submits those jobs to the clusters. HBase is a Hadoop's database, which is NoSQL data store, which can store large amount of data, that is gigabyte, terabyte, or even petabytes of data in a table. It is useful as MapReduce is not designed for interactive processes. Flumes is a distributed real-time data collection service. It effectively collects, aggregates, and moves data in large amount. Scoop provides a method to improve data from tables in relational databases into SDFS. It supports easy parallel database import and export. The user can insert data from RDBMS to SDFS. It also exports data from SDFS back to the RDBMS. Hue is an open source web interface that supports Apache Hadoop, and it ecosystem licensed under Apache version 2. Hue aggregates the most common Apache Hadoop component into a single interface and targets the user experience or user interface toolkit. Mahout is a machine learning tool to support distributed and scalable machine learning algorithms on Hadoop system. It helps in building intelligent applications easier and faster. It can provide distributed data mining functions combined with Hadoop. Spark is an open source clustering computing framework with in-memory analytics. Whereas Oozie is a workflow management project that allows developers to create a workflow of MapReduce job, including dependencies between jobs. The Oozie server submits the job to the server in the correct sequence, whereas Zookeeper is a centralized service for maintaining configuration information to provide distributed synchronization. It contains a set of tools to build distributed applications that can safely handle parallel failures. Zookeeper was designed to store coordination data status information, configuration, location information about distributed applications. So this was all about Hadoop ecosystem. Now, who uses Hadoop-like framework? Well, there are 330 companies reportedly using Hadoop in their tech stack, including Google, Yahoo, IBM, Oracle, Microsoft, Facebook, Amazon, Airbus, Uber, Netflix, and so on and so forth. More than 1100 developers on StackShare indicate uses of Hadoop system. Also, there are many other, including many universities and research labs using Hadoop. Google is the inventor of the MapReduce computing paradigm. Yahoo and Apache are known for developing Hadoop open source of MapReduce. Besides this, Hadoop has its own limitations. There are security concerns when the data is being splitted and assigned to different data nodes, which may be misused, or it may become difficult to maintain confidentiality and integrity. The MapReduce processing technique is vulnerable in nature due to master and slave architecture. Deploying Hadoop for relatively small and less complex data is not a good idea, as it is really not fit for small data. Development in terms of improvement is still going on to solve the scalability issue, if at all is there, for a given application. To summarize, we can say that Hadoop is an open source framework made available from the Apache Foundation. It is based on MapReduce processing technique and a programming model for distributed computing based on Java. It is capable of processing big data in a distributed fashion across clusters of commodity hardware. Hadoop provides reliable shared storage and support fast processing for analysis and making quick decisions. So that's all in this video on introduction to Hadoop. Learn more by taking up quizzes available on my Google site. Thank you.